Hello everyone, welcome back to this tutorials. So today we continue working on our terrain. From the last tutorial we have cleared all necessaries or unused terrain layers. As a quick example, we only have left for terrain layers only which one we need. So in really short summary, we removed all the layers which one was not used, or in other words, we didn't found any pixel on that terrain. So we removed that one and we insert our 5 layers, which one is a really key point for us in a certain area and for each terrain. This is really allowing us to interact with the layers in order which one we want. So what I'm trying to say that, and each terrain, which one I have quite a lot here, the third terrain will be always same, and that terrain is already inserted from the last tutorial, even though it's not used. So please watch that terrain at least for about 5 minutes. First 5 minutes I explained the scenarios where you should not use this approach, or use cases if you have facing some issues, and all the benefits if you use this approach and you write the code not only for your own practice as a coder, but for game developing benefits. So let's continue in our tutorials. I do apologize if the code looks different from last time. I have recorded the lessons. I have recorded this lesson, but my computer has frozen, and for some reason I have damaged, I think, GPU. So I'm ordering new and waiting for a new GPU came out. Well, not came out, for delivery. So I hope so it will be successfully recorded this. So if the code it looks different for you, and especially I'm talking about this line, please pause the video. I'll zoom a bit for you guys. I think 160 should be okay. So please pause the video and adjust your code. I think something here, exactly here, was added from a last tutorial. If you need to remove, please remove and come back here, and we can continue what to do. Okay. So one of the things we can say straight away is about we need to interact. I wanted to get you guys to showcase the issue which one I'm trying to sort at the moment. Maybe I just actually I come back for, oh sorry. I think the best way would be I just actually show you case. So when we're interacting with, not interacting, but at this code line here, this code line actually a map. We actually terrain data. We asked for terrain data to get alpha maps, and we pass the positions, and we pass the size of how much we want to get of data. How much of data we want to get in a square, by the way, size. So if you look here in my awesome drawings, this is a location of a game player we want to, in a world where we want to get some alpha data, and we pass this, and we pass exactly same position where the player is, and we're asking to get. Oh, sorry. And we're asking for alpha map, return that much data. And if someone already can see the problem, you're on the right path. The problem is that all the data is not around the player. The player is not in the middle of the data. So when the player walks, and let's say he walks, I don't know, he walks down. Just downline. the path which one we will be the path which will be always drawing will be only on the one side, not around the player. So a player is only interacting in X and Y. To address this issue, let's draw this one a bit better. I don't know how to. Okay, so let's draw the same. Okay, this is a player. Oh, sorry. So this is a player again, and this is the data we're asking for. The data is always the data which one we're asking is in the Y and X position too much. So what we need to do is we need to do really simple thing. We need to get Y position, which one we have already. We need to divide in a half, so we have 1/2 of X and 1/2 of X here, and then we need to subtract. We need to subtract that amount from X position. So if we do this, suddenly all this square which one we're requesting will be sliding by 1/2 X. So our position will become here. If we repeat the same procedure for Y, our player will be in the middle of requesting data. I hope so. I'll explain it correctly. Not correctly. What trying to say. I explain it well, and you will see. Hold on, guys, and you will see it on the code. So to do that one, the best place or the best location I've found to do is not here when we calculating the request. We just do here. We adjust a map position before we request. So a map position, which one we already have, .x, is equal to new position. And let's get back to our drawing. So we need to find how much data we're asking in X coordination. So how much data we're asking on X is terrain painter request dot size paint size dot X plus terrain request painter request dot paint not paint, sorry, fade size dot X. And that's how much we know. Now we know how much of data and X axis we are requesting. So now we need to divide by 2. We need to divide by 2. Okay, we divide by 2, and that's cuts in a half. We find just a half of X. Okay, that's brilliant. Now we need to make sure that this number is integer. Okay, we don't need to cast it into integer. That's it. The main thing what I find myself, oh yeah, I forgot about this one. We need to subtract. So yeah, the next step, when we find the half of the X of requested data, we need to move by half, and the axis will be subtract because we going left, not right. So we subtract terrain paint size plus fade size divided by half. Additional to here, why I put in the brackets is adjustments. Because it's a pixels and it's an integer as well. So anything in decimal point will be ignored. Like the compiler will ignore any decimal point of this division. So additional to this ignorance of the decimal point, you need to take into account your camera position as well. So because I'm using orthographic camera and it's quite angled in a certain angle, I find that if I add 1 pixel to compensate, not compensate, but to make look brilliant, to make look like a person is actually standing in the field he is interacting with, I find that plus 1 pixel is exactly what I'm looking for. Cool. Okay, that's first time. Something strange. Oh, okay. Anyways, let's repeat the same for. We need to repeat the same for actually a position of y. Only one thing I just thought now. We're working with we're working with square. We can actually say that we would like to do, sorry. We can actually say that a map position of y is equal x and don't do the same calculation. But I don't want to remove possibility from us, option to use not square but rectangle. So that's why I don't want to make x is equal y, even though this is the case for it now. So if we do this, we get a half, and we move by half, and we do the same for this. So our person will be in the middle of requesting data plus 1 to compensate the camera looked. Okay, that looks great for me. Now we just need to test somehow. To do that one, let's just first of all, let's check. So what I want to trying to say to check. So we have a grass layer. This one you can see here. Let's make it smaller by 5. So we have a grass layer, and we will have some random flowers. Of course, it won't be like that, but intensity strength will be 0.1, and we have some flowers, some locations, and etc. etc. So it will be grass and some random flower texture in it. So that means that we have a layer 0 of the grass and the layer 1 of the flowers. In our code, let's check first if a map, which one we just read, at location A and B and layer 0 is greater than, the value is greater than 0. If this is the case, so we want to decrease that value by a terrain painter request paint strength. In the same way, we want to increase at A and B, not 1, but layer number 2. If you look back in here, we have layer 0. We have layer 0 here. We have layer 1 here, and we have layer 2. So we want increase layer 2 by terrain painter request paint strength. Okay. So this is a really quick test, decreasing the grass layer and increasing the dirt / mood layer. Okay. So I have paused recording and fixed my Visual Studio because, as I mentioned, I have quite a lot of issues with the GPUs, and I have just recently rewritten my Windows. So that was the first time I opened Visual Studio. For some reason, it was not synchronized with Unity, but after I fixed this issue, I done some few silly mistakes. So paint size is a float; it doesn't have .x. And same applies here as well as here. This is a float values, which one we work with. And we divide by 2. Okay, we have one bracket missing here, and a bracket here. And that's it. That's why it was a really strange, it's really strange actions, not actions, things going on here when I was typing it. But yeah, now it's working. So let's build Control-Shift-B to make sure there's no more mistakes in our script. Okay, cool. No errors. Should be no errors here as well. Okay, that's really strange. Let's turn off this one. Okay, testing time. Much better. Much better effect. So now we can see that it looks like our person is actually walking on the path he is affecting. And if we want to actually compare that, so let's compare what was before with what we actually done. So these 2 adjustments we just type in, let's comment them out, and I'll demonstrate the main issue with which one we're trying to sort. By the way, this error, which one I'm receiving, is because of drivers is missing for 3D mouse. I'm not installed yet. I want to do one tutorial as quick as I can before actually trying to sort every single application I need to reinstall. Cool, let's go back to the game and let's rotate. So this is without adjustment. And the more clear the path is becoming, the more clear you can see how the path the actual person is walking and terrain we painting is offsetted. And this is a really visible in this corner. And oh, Jesus Christ, I just messed up. Yeah, let's make a new one. And it's really visible when the player is on the bottom, on the top, and in bottom. Our corner when we're looking in, our angle when we're looking, it looks like 50% times it is on the right path, but another 50% is on the side of it. Don't forget we are rotating and camera is put in angle. But as you can see here and here is the 2 points that it actually really does not match how it should be. To fix it, what we've done before, we just uncomment the offsets. Cool, one step at a time. Now let's interact with all 5 layers. I want to introduce one of my approaches for, how to say, for limits of the number, to make sure the number is not going out of above or below some certain number. I'm implementing just if condition. I know you can use math some functionality here, but I'm not really relying on libraries for some sort of really small how to say, really small function I need. So instead of relying on the function and calling library, which one has a lot of error checks, or maybe doing something else more than I would like it does. So I prefer to use a one code line myself and have full control of it. What I'm trying to say is, etc. this code line. We decreasing by a terrain painter request and paint strength, but for some reason, like etc., the developer enters a huge number, or it's not add up to 100%. So let's say you take, I don't know, you take number 11 and you keep adding up, and you will cross, sorry, you decreasing by 11 and you will go below 0, because every single time, well, let's say number 2 is greater than 0, let's decrease 11, etc. And you get, -9. So to do that one, we saying if a map at location A, B, layer 0 is below 0. By the way, I forgot a really good one. I forgot to start with if a map is lower than 0. We want a map at A, B, and 0 become 0. So anytime before we update our terrain data alpha map, if this pixel at coordination of A and B and layer 0, the value of that layer is below 0, get back to 0. The next frame, this will become false. It never will be executed again. And this if condition is just comparing true and false between two values. It's really efficient. So instead of you using some external library with some function about giving a number of boundaries and not allowing to get below or above something, you just write if condition. That's I prefer to do. So we need to repeat this one, by the way. We need to repeat this one for if we decreasing the layer of a grass, we need to decrease the layer of flowers as well. So if a map at A and B, layer 1, which one is the flowers, is greater than 0, we want to decrease that layer as well. Decrease by terrain painter request dot paint strength. Oh, silly me. We should use painter strength adjustment, by the way. Which one? This adjusts depending which one pixel around. Back to the story. We want to paint. We want to paint much higher strength around the person and the fade when it goes away. So instead of using directly terrain paint strength, we use paint strength adjustment for here and here. Okay. Here I want to implement as well the same boundaries. I wanted to make sure that if for some reason at pixel A and B layer 1 becomes below 0, I wanted to make sure that this pixel get back to 0. And this never becomes true again because it stays on 0. So yeah, we just interacted with 2. Now we want to bring the last step on this layer. So the grass is greater than 0. We want to decrease the grass. Additionally, we want to decrease the flower layer, and we want to increase our half mood, half grass layer. Oh yeah, by the way, by the painter adjustment. Here, I want to implement again the boundaries. So if for some reason a map at pixel A, B, layer 2 becomes greater than 1, I want to this pixel get back to 1 before we update our terrain. So this is how we implement layer 1. Well, a step, let's say call it state 1. Now we have a state 2. So we removed all the grass, and now we have 100%, which one represent as 1, our half mood, half grass layer. Now the person or NPC is still walking on that location, so we need to now introduce a full mood, so we'll remove the rest of the grass. So to do that one, so we go else if a map at A and B layer 2 is greater than 0. Don't forget, this becomes only true when the grass is at 0, and it will be in 0 and not below 0 because we've done boundaries. So that means that at the same location we have mood at 100%. And this is the case because we was decreasing the grass by the same amount when we increasing the mood. So that's mean when this hits 0, the layer 2 will hit 100%, and then we go here and we will start checking this condition. So this condition is when while this is greater than 0, we want to decrease. Just copy paste this one. We want to decrease the layer 2 by paint strength adjustment, and we want to make sure if it gets for some reason below 0, we want to put it back to 0. We don't have additional layer on here. We just have layer 3, which one we want to increase. Okay. And that's it. Actually, that's all what we need to do. Okay. Let's do some testing. Oh, before we continue, I really would like to zoom in a bit to give you a full. So we have a grass, and we start painting like half grass, half mood layer. Which one is number 3? Actually, I should put some flowers to see how that will be affected. But yeah, you can see it's getting that layer more and more clear. After this layer will hit 100%, a third layer, array number 3, will start appearing, and that grass should to start fade away. Yeah, I can see it's already doing. And I don't know how many exactly circles are done, but I'm assuming it's 10 per one layer, 10 per one state. So it should be about 20 circles, or 20 times you need to step in this one. Of course, this number could be increased, how many times you need to step, if we just decrease the paint strength. So let's say you're painting only 5% each time someone is stepped in. So that's, you need straight away. You need 20 times per one state, and you have 2 states, makes 40 times. Yeah. And as you can see, that's our results. Okay. I want to test a bit more and introduce you guys really quick for, let's call it a nav mesh. So for our boy, we need to add nav mesh agent component. I enable now. And you need to add this one. Next, what you need to do is actually open navigation and press bake. Bake. For me, we have only terrain at the moment, so it's quite simple. I'm not including this, what's called mountains. So for our purpose, it's more than enough only the terrain. So you need to bake this one to actually see the walkable area. Now, getting back to Inspector, we need to open one of the scripts I have written. And I wanted to write the script together with you guys. So if I put the button aside, 1 second. So get this one back, put this one here, drag this one here. Well, actually, we can go all. I think it will be quicker just to go all this one really quick. So I created in this line, I create a game object, which one is this destination parent. Destination parent is a game object which one holds multiple other objects, which we assume as destinations for NPC to walk. We have an empty list of destinations, and we have a nav mesh object called agent. So on the start, we want to actually for loop for every single destination parent child counts, and we add every single child in that on that parent to the list. In other words, if we want to see here, we have destinations game object here. I'll pull it back, and that destinations have multiple childs. Let's activate it. So it has sphere 1, sphere 2, and so on and so on. I just made spheres to be more visible. And it has in total 9 locations to walk with. If we zoom out, this is 9 locations for NPC to walk. And all this object is under one parent. So here in the script, we walk we go through every single child under that parent, and we add to the list. So we have reference to every single that destination. Now we're saying agent. Well, we assigned our agent to component. We added to his game object, and we say at the start we're saying gets a destination and random range. So this is falls into 2 things. So when you're saying destination, you need to just pass the game object. So Unity has brilliant nav mesh, and it will using AI to get to that destination, to that destination's object's location, and it bakes the walkable areas, and it gets avoid all the other obstacles, and it's really avoiding each other nav mesh agents as well. So we need to pass the game object. And we go back to the list of the list of our game objects, and we type the random range, and we're giving 0 and destination count. So we know it's 9. We don't forget the count, it will bring 9. But if you hold mouse on the on the top of a range actually function, it says returns a random integer number between min inclusive and max exclusive. That's really key point, exclusive, because from 0 to 9 is way too much. We need destination has members from 0 to 8. 8 is a maximum number we can go. So when we put destinations count, which one is 9, but it's exclusive. This is a key point in the standard random range, that the number of maximum is not included. Transform dot position, 3D space, and in update we can ask agent remaining distance. So how much distance is still left to the person to walk to that position? If it's only 0.1, so this is equal to 10 centimeters, because Unity using meters. If it's less than 10 centimeters, agent set destination, and we get another random destination. So that's it. For a testing purpose, we can actually make this game object walk until it gets 10 centimeters to object, get a new destination, and keep walking into new location. That's all. That's how simple Unity Nav Mesh is. Of course, it has much more functionality, much more implementation and options to actually set, like the size of agents. Which one is humanoid? You can actually create another class, like horses or cars in your game, or even birds if you want. You can areas to actually change the areas you want to classify. And the main thing is the costs, which one I will cover later, about our NPC will actually use least costly path to get to the destination. And that's a key point. To our NPC use the same path of someone already made. So the cost will be decreased every single time another person walks that path, and increase its, I don't know how to say, pathability. Let's get back in the game and let's see how it works. Now we can go on a maximize. We don't need to actually control it ourselves. Okay. Don't forget, it's 10%. It's quite a lot. Okay, for a full, we will stop here a bit, and what I want to do is actually to paint a bit flowers. So I want to make sure we don't have any problems with some flowers in here. So with brush strength, I want to do 0.1, and I wanted to jitter about 0.1. So we have the jitters. I want a brush size to be 5 and jitter by 1. Oh, that's a lot. Okay. So this is a maximum. 0, 1. Okay, and we want a bit rotation to jitter 1. Oh, that's a lot. 0.2, and I want a shape like this, and brush size a bit, jitter a bit more. Cool. It's really quick. Just making sure. Okay, and now I want to add a bit more boys on the field. They should all have. Oh, okay, I added the wrong ones. Boys and girls, which one I have? The snap meshes here. Okay, we have 6 of them, and maybe decrease. Okay, because I know some errors, not errors. I know the issue about we're facing, so I wanted to discuss these issues in next tutorial. And here we can see the problems we will be addressing the next tutorial, especially like taking one of the paths. So this is a request of people who pass this location before, and because they're walking faster than we actually addressing their frames, we receiving much larger number of requests when we actually just addressing them. I put it this way. So I will be discussing in more details exactly this issue, but this is a really nice demonstration what's happening. So that's all for today. I'll leave a bit speed up video of this one as if everyone want to see how we end up after, I don't know, a few minutes of this walking. So thanks for your time, guys, and we'll see you in the next tutorial. Bye.
now go.